Alright, so welcome to the video here for lesson number 2. So we talked about today the unit circle and how we could use the unit circle to extend the domain of sine and cosine outside of a regular 0 to 90 degrees. So the first one here that we have is talking about the sine and cosine of 240. So to draw a quick little sketch here for that, so if I take the x and the y axis, if I rotate around 240 degrees, I'm going to end up somewhere here in quadrant 3, sorry. So I know I'm going to go around 180 and then I'm going to go 60 more. So the angle that's in my triangle there is 60. So that's the reference angle. That's the angle we're using to reference back to 240. So off to the side, as soon as I see that it's going to be 60, I'm going to draw my 30, 60, 90 triangle. And then I can start to talk about the coordinates here that are creating this triangle. So I know that the vertical side is going down and the horizontal side is going to the left. So I know both of these are going to be negative. Also, all students take calculus. T stands for tangents positive, all others are negative. So we're talking about the sine of 240. We're actually saying it's the negative sine of 60. And we know from our table, my triangle here, that the sine of 60 is square root of 3 over 2. And then if we do the same thing for cosine, so the cosine of negative, or positive 240, sorry, is equal to negative cosine of 60, which is negative 1/2. Now we talked about in class how we could check these. If you type them in the calculator, you can then check the decimals and see if the decimals match, all that good stuff. Let's take a look at 2. So 2 tells us that we have this angle. This tells us right here between 0 and 90 we are in quadrant 1. And it says the sine is 1 over the square root of 3. What is the value of cosine for this triangle? So if we think about this triangle, put it over in quadrant 1, theta is here, opposite hypotenuse, so I could figure out that the missing side is 2. 1 squared plus 2 squared. If we do that, we get 1 squared plus 2 squared equals, that would be 5 squared, so that doesn't make sense. Hold on a second, it's not 2. So let's see what this comes out to be. I think it's a radical, actually. So if we do 1 squared plus b squared equals the square root of 3 squared, we get 1 plus b squared equals 3, so b squared equals 2. It's actually radical 2. So we get b equals radical 2. So they want us to know what the cosine of this is. So the cosine of this angle is going to become the square root of 2 over the square root of 3. I know that because of adjacent, hypotenuse, opposite, so SOHCAHTOA, and I can rationalize that, if it asks me to the square root of 6 over 3. It then says, what does your answer change if this was in quadrant 2? That's what this tells us. Well, if it's in quadrant 2, I know that the cosine value is negative, so if theta is in quadrant 2, the value will be negative square root of 6 over 3. Let's go to 3. 3 tells us that the vertices of a triangle are connected by the coordinates, and it gives us 3 coordinates. So if we just make like a quick sketch here of what that looks like, it doesn't have to be perfect. I know A is here at 0, 0. B is at 12, 5. And C is at 12, 0. This creates a right triangle with sides of 12 and 5. And the hypotenuse is 13. That's a Pythagorean triple. If you're not sure where that comes from, just do this, and it'll give you 13. So then it says find the sine and cosine of theta. So if we want to find the cosine of theta, again, we have to show the adjacent, hypotenuse, and opposite. We remember that from geometry, I hope. So that becomes 12 over 13. Same thing for sine. I don't know why I did them backwards, but sine would be 5 over 13. Both of these are positive because they're all in quadrant 1. If one of these points had a negative coordinate, it would be in a different quadrant, and then things would be very different. Cosine of theta is equal to a negative value. This tells me we are either in quadrant 2 or quadrant 3. So I'm going to draw two potential triangles. I'm going to draw the quadrant 2 triangle, which would have a adjacent side of 4 and a hypotenuse of 5. And I'm going to draw the quadrant 3 angle, which would have an adjacent side of 4 and a hypotenuse of 5. Both of these would have vertical sides of 3. But notice, in quadrant 2, the vertical side of 3 is going up, so it would be positive. In quadrant 3, the vertical side of 3 is going down, so it would be negative. So the sine value of this angle, because it can be in either quadrant, can either be plus or minus 3 over 5. If it's in quadrant 2, it's positive. If it's in quadrant 3, it is negative. The next one says, use the unit circle to explain why those two sine values are the same, but the cosine is not. So we know that if we are at 135, so if this is 135, this angle is 45. So the reference angle is definitely 45 degrees. Now here is the problem. The cosine value is negative because it represents the x-coordinate. So we can say something along the lines of, in the unit circle, the x-coordinate is negative if it's in quadrants 2 or 3, which means that the cosine value of that angle is going to be negative in quadrants 2 or 3. That's why it's negative there. Right? So if you were to think about me drawing the triangle over here in quadrant 4, the x-coordinate would be positive, so cosine would be positive. The reason why the signs are positive is because the y-coordinate, or the vertical side of the triangle, is going up. Right? If I have a y-coordinate that's going up, it's a positive value, so these are both going to be the same. They're going to be square root of 2 over 2 and the square root of 2 over 2. This is going to be negative square root of 2 over 2, where this is going to be positive square root of 2 over 2, if I was to go through and do all of the work. Okay. But the reason why with the unit circle is because of where you are located. Number 6 says that the sine of 50 is A and the cosine of 50 is B. Find the value of the expressions in terms of A and B. So if I want to find the sine of 130, I know that 130 has a reference angle of 180 minus 130, so 50. So I could say the sine of 130 is equal to the sine of 50. I know it's equal to the sine of 50, and it's positive because it's in quadrant 2. So this first answer is just A. 290. 290 is in quadrant 4, so I would do 360 minus 290, which gives me 50. So this is going to be the cosine of 50, but 290 is in quadrant 4. Because I'm in quadrant 4, I know that cosine is positive, so these are going to be the same. So this one's going to be just B. 230, that's in quadrant 3. So 230 has a reference angle of 50 also. So this is going to be negative sine of 50. It's negative because you're in quadrant 3, so this is negative A. 40 is an interesting one. This one there's no reference angle for, but we remember something is that the sine of an angle is equal to the cosine of the angle's complement. So the sine and cosine here are going to wind up helping us. So the cosine of 40 is equal to the sine of 50, which is equal to just A. So A, B, negative A, and positive A. That's your homework. I know I went through it quick, but remember, you could always pause the videos, watch them again. Try the questions first. Don't just copy it down. That would be a good thing for you. I will tell you, and this goes for either of my classes, either Accelerated or Regents, if we finish Lesson 3 this week, the day after we finish Lesson 3, you will have a quick quiz. So just keep that in mind. Accelerated for sure. Not sure about Regents. It might be when we come back from break. All right, so keep working on this. Keep looking at why things are what they are. Right, I think the videos will help because I'm talking through things again. So just keep watching them, and we will be in good shape. Best of luck.